All right, everybody, today we're going to look at graphing linear inequalities. Okay, so when we say linear inequalities, what we're talking about is basically graphing lines. However, what we're going to add to that is the inequality piece. Okay, so what we're talking about is instead of graphing y equals 1/3 x plus 2, it might be y is less than or equal to 1/3 x plus 2, or y is less than 1/3 x plus 2. Think about each of these. So when you graph this, okay, and you can probably remember how to graph it, you're graphing a line, right? And that line represents every single solution to that equation, okay? Where it gets really awkward then is when you're graphing here, okay? So you're going to graph that same line, right? But that only gives you the solutions to y equals 1/3 x plus 2, not all the places where it's less than. Okay, so just like you have with your number line, there's going to be some element of shading. What you're going to end up doing is you're going to end up shading one side of that line or the other to account for not just the places where the equation is true, but to also account for the places where it's less than, right? So not just places where it's equal, but where it's also less than. And then when we get to this one, it's really complicated because it's very similar to the last one, but we're going to have to come up with a way to indicate that the line, which is where the equals part happens, doesn't count. Okay, and we'll talk about how we kind of manage that. Basically, what we're going to do is we're going to change, instead of that being a solid line, for any time where it's less than or greater than 2, anything without the or equal to, instead of doing a solid line like that, we're just going to make a dashed line. Okay, my eraser's a little bit big, so didn't make a great, there we go. We're going to make a dashed line instead, similar to doing an open circle on a number line. Okay, so first we're going to take a look at how to graph these things individually. Okay, so we're starting off with the equation y is less than 1/3 x plus 2. And what you're going to do is really the exact same thing that you would do for this if it was y equals 1/3 x plus 2. You're going to use slope-intercept form. That's my y-intercept. I'm going to put that on my y-intercept of 2. And then I'm going to go up 1 over 3 to make some more points. You can do this as few or as many times as you want. You can also do the opposite. I'm just going to try to fill this up a little bit. And then that's as many as I can make right here. Okay? Now, there are two major differences between graphing an inequality versus graphing an equation. One is you have to decide whether you're going to connect it with a dashed line or whether you're going to connect it with a solid line. And it's the same decision you made when we did inequalities on a number line, open circle versus closed circle. If it doesn't count, use the dashed line. If it does count, use the solid line. Since it's not or equal to, we're going to use a dashed line for this one. Okay? Now what we have to do is we have to figure out what side we are supposed to shade on. Basically, we have to decide, are we going to shade the entire graph, everything below here? Is that where all the less than points are, or is it above the line? Okay, and are we going to be shading completely on the other side there? Are we going to be shading up here instead? Oops. Or are we going to be shading up here instead? All right? The way to figure that out, and the way that I've always kind of taught that, is to use a test point. Okay, so basically, this is a little bit trickier. There are some points where you could just say, yeah, less than is down, greater than is up, and we'll talk about some of those in class. But I think the safest way of doing it that works for all examples is to use a test point. So what I'm going to do is 0, 0, which is right down here, is not on my line. Okay, so what I want to do is I want to plug in x equals 0 and y equals 0 into my inequality and see if it's true. If it's true, I'm going to shade down because that's where 0, 0 is in relationship to my line. If it's false, then I'm going to shade up because I don't want to include that in my solution set. So if I plug in 0 for both x and y, I get 0 is less than 0 plus 2. That's true, so I'm going to shade down. Now you could color this in a whole heck of a lot. You could just kind of do some light shading. But what this indicates to you is this. The line is where we start, though we're not going to count it, and all of those points that I just shaded in would make that inequality true. What I'd like for you to do is try this next one. Again, you are really just pretending that this equation is 3x plus 5y equals 2. You're kind of doing the same steps, and then again, it's just the two decisions at the end. Do I do a dashed line or a solid line, and do I shade above or below the line? Pause and try to do that. Okay, so if I was graphing 3x plus 5y equals 2, what I might do is make a little table of values, okay? And ideally you'd get 3 points in here. Maybe you will, maybe you won't. 1 and negative 1 works really well. And let's see what else is going to work well. Oh no, I'm sorry, that would be negative 2. I went backwards. My fault. So instead of 1 and negative 1, let's do that backwards. Negative 1 and positive 1. Sorry about that. And then 4 and negative 2 will also work, because that would make 12 and negative 10. So let's graph those. Negative 1 and 1 is right here. 4 and negative 2 is right here. And what I would suggest you do at this point is either use a really nice straight edge or just figure out the slope. Looks like you're going down 3 and right 5 to make some more points. Or we could go then up 3 and left 5 to make some more points. The next thing we have to decide is solid or dash line. Since it's or equal to, greater than or equal to, we do want to count it. So we are going to use a solid line there. Now what gets really weird here is because I don't have a straight edge on my smartboard, I'm not sure whether my equation goes through 0, 0 or not. So I don't want to use 0, 0 as a test point. So this time I'm going to choose 1, 1 as a test point, okay? And I'm going to check out x equals 1 and y equals 1. If I get that, I would get 3 plus 5 is greater than or equal to 2. It is. So I want to shade above the line because that's where 1, 1 is located with respect to my line. Okay? That's really the basics for graphing linear inequalities. Okay? When we get to class, we're going to talk about how to apply these to actually a system of inequalities. Instead of just graphing one at a time, we're going to be graphing two.